Hi there. We're getting started in geometry. This is actually the very first lesson that we'll do in our geometry book. And you'll find that in this first lesson there's a lot of terms to learn, a lot of notation, and really even the whole first chapter, because geometry is kind of a different deal than algebra. And so it's the first time you've been exposed to so much stuff that's visual, and there's so much different notation that we use. So bear with me, a lot of this is kind of I don't know, I don't want to say mundane, but you know, it's here's a definition, here's what it means, and just getting you familiar with some things so we can move forward with this information. All right, so the first thing, I missed that slide, it said there's three undefined terms: points, lines, and planes. So there's not much in math that we allow to be just undefined and we just accept it. But here are kind of the basics of geometry. You have points. Here's an example. A point, it indicates a location. It has no size. It's just a spot. And the naming for it is a capital letter. And you can name it any letter, but it has to be capital. We're picky about that because a lowercase a means something different. All right, so try to take note of these special notations. If we have a line, all right, a line, we kind of all understand what a line looks like, but like as a definition, trying to explain what it is, it says it extends in opposite directions, so that's why we put arrows on them. It has no end to it, but there's no thickness to it either. It's just kind of showing a direction. Now, it can contain infinitely many points. In my diagram, you can see point A and point B that I've stuck on that line, but I could put in a point C and point D and an infinite number anywhere on that line. The naming for lines, the quick way is to use a lowercase script letter. So I used a lowercase l, that's kind of a common letter we use to name lines. Or you can also use 2 points that are on your line. So in this case it's AB, or I could also call it BA. That doesn't really matter the direction that you write it, but do notice that above there I have this line. And notice that it does have the arrows on it. That's important for what's coming next, but that's how you could name a line. All right, the third one is a plane. Now, a plane is like a flat surface, and it extends in all different directions. There's no end to it. Of course, it's hard to draw that, and it's hard to put arrows on a flat surface. So we're going to draw it so it kind of looks a little three-dimensional. You can see it's kind of drawn with a parallelogram. That's typically how we would draw a plane. Understand that it would continue in all directions. It's a flat surface. It would contain an infinite number of points or lines. The quick way to name it is to use a capital script letter. The line used a lowercase script letter. This is a capital script letter. Another way to name it is to name what's on it. If you can use 3 points that are on that plane, in this case I've got A, B, and C, we can name it with this little parallelogram symbol, ABC. But you have to pick 3 points. All right, let's go a little deeper into our points, lines, and planes. When we talk about collinear points, collinear means that these are points that are going to lie on the same line. They share this line, collinear. They lie on the same line. Now, when you pick 2 points, I'm going to pick these random. Here's 1 point, and here's another point, and those are just random. Any 2 points, I could draw a line through. So if I'm talking about collinear points, I have to have more than 2. I'm going to have that 3rd point to decide if it's collinear or not, because I know that these can line up and create a line. The question is, on this 3rd point, is it going to be collinear with the others? If I stick it on the line, just like that, then these 3 points all line up. They are considered collinear. If I had put that 3rd point on the outside of the line, then they would be non-collinear. Same thing works with coplanar. When you're finding points and whether they lie on the same plane or not, any 3 points, I got 1, 2, 3 points. Any 3 points can kind of designate a plane, if you can imagine that plane right there with these 3 points on it. But if I want to talk about coplanarity, that's tricky to say, coplanarity, then I have this 4th point, and this 4th point is like above the plane or maybe below the plane, but it is not on the plane. That would be non-coplanar. If I pick another point that's down here on the plane, that point would be coplanar with these other 3 points. All right, so given those 3 terms, let's practice a little bit. The first one here says, what are 2 other ways to name line QT? All right, notice where QT is. First of all, QT is this line right here. Now you can see this dot, dot, dot. That's just trying to show you kind of three-dimensionally. Some of you are going to be like more artistic and understand this better. Some of you not so much. But this dot, dot, dot just shows it's kind of underneath the plane, so you can't really see it. And then again, you can see it down here, so it's not dotted anymore. But this is your line QT. And we're looking for other ways to name that exact same line. Well, the first thing I'm going to do is grab my shortcut way, and you see this lowercase m right here? That's my quick way to name a line, is with your lowercase m. So that would be one option. Another option would be to pick any other 2 letters, or to switch the order. It says QT, but I could do TQ. But the trick, make sure that you put a line with the arrows above it. You could pick another 2 points. Maybe it's T and N. They're both on there, so I could go TN. Or I could go the other way. I could write it NT. That's fine also. I could do NQ or QN. It only asks for 2 different ways, but I'd have a lot of different ways I could name that same line. Part B. What are 2 other ways to name the plane P? Well, look real quick for your shortcut way, and that's the capital script letter. Now, it's hard. They're not always great about putting these as script, but that P right there, oops, that was kind of ugly. That P should be a script. So when we write it, I don't know, whatever you want to do to make it look fancy, and you can put a little swirl or something, I don't know, whatever you want to do. Make it look like it's a script P. Because if it's just a regular capital P, that's a point. There's a difference. All right, now that's my shortcut way. Any other way would have to be to use 3 letters. If I'm going to use 3 letters, I need to pick 3 letters that don't line up on a line. I didn't mention that earlier. We'll talk about why later on. But you're going to pick 3 points, and then you remember that you do this little parallelogram picture here, and you pick 3 other points that I guess they named plane P. I'm sorry. I wrote cursive P, but that was what they were saying, so that maybe wasn't as important to write that, but I did want to note that it didn't really look a script. All right, pick 3 letters. I don't know, R, Q, V. Or maybe parallelogram V, S, Q. Or parallelogram V, well, and let's make note of this too. Do you see how S, Q, and R all line up? So whatever you do when you're picking those letters, you have to make sure there's a V in there. Now what that means, okay, so I could also do like VRS or something like that, and I could switch the order of all those letters. None of that mattered. Lots of different ways that I can name that plane. All right, last question here. What are the names of 3 collinear points? Collinear points mean that they lie on the same line. And then it says 4 coplanar points. Let's look at the first question, the 3 collinear points. I got to find 3 points that lie on the same line. The thing is, I have a couple options here, because I have this line right here. This is a line, so these 3 points would be considered collinear. But I also have this vertical line coming in through here. That's a line, so those 3 points could be collinear. So if I'm going to list out what are the names of 3 collinear points, I'm just going to pick one of those. Let's go ahead and pick RQS. Now I'm putting points, so put commas between these, R, S, and Q. These are all collinear points. And then I go to the 4 coplanar points. Now I have the yellow plane here, so when I'm looking at this, I'm trying to find 4 points that all lie on that yellow plane. Be careful, because remember that this P here, this P was actually the name of the plane. It was supposed to be script. It wasn't really, but that's not a point. So I have to pick the other points on this plane. So looking at it, I've got this V, I've got this R, this S, and this Q and this S. Those are my 4 coplanar points. So the second part of this, I'd pick the V, the R, the Q, and the S. All right, so the next thing is a got it kind of section, and that got it always is where you're going to practice on your own. So I'm going to give you a minute, see if you can answer these questions here, and then when you're done, you can start the video back up again. So go ahead and take a minute and pause it. Make sure you know how to do those 4 before we move on. Pause your video. All right, let's see how you did. On that first question, it says, what are 2 other ways to name line RS? First thing you can do is you can always switch the order. Remember that that's a different way to write it. It means the same thing. Then I tried doing it with some other points that all lie within that same line. I got QS. You could have written SQ. That's fine. QR, RQ would have been fine. All right, on number or letter B here, I got a little ambitious up above. Named 2 other ways to name plane P. Well, we named several ways, so you can look above to see some other ones. What are the names of 3 other collinear points? All right, well, we said R, S, and Q. We were using this line. You could come back and use this vertical line we talked about. T, Q, and N all line up on the same line. And 2 points that are not coplanar. All right, on the yellow plane here, everything that's on the yellow plane is considered coplanar. So I had to pick 2 things not on the plane. I picked T and point N there as points that are non-coplanar. As we talk about lines, there's actually certain parts of a line. Sometimes we're not using the entire line. And here are some other terms that we use. We use the term segment. That's the part of a line that consists of 2 endpoints. Notice in my segment, there's no arrows here, not at either end. It just has 2 separate endpoints, A and B. To write that, we're going to write AB, and instead of putting a line, we put a segment, and there's no arrows on it. The direction you write your A and B does not matter. Array is a part of line that consists of 1 endpoint, and then all the points on the line on one side of that endpoint, indicated with an arrow. All right, so in this example, I've got A, and it is going towards B. You can see from the arrow, A is going towards B. A is the endpoint, and we're talking about all the points to the right of that. Okay, so that's this right here, A towards B. Now I have this is a typo. Well, no, I'm sorry, this is not a typo. I did fix it. I had it different earlier. It's just written, do you see how it's backwards here? But you have to be careful on rays because of the symbol, since it has an endpoint and it has an arrow, the endpoint has to be in the right place and the arrow has to be in the right place. This is starting at A and going towards B. Either way I've written this is okay. This is probably the preferred way. We typically will draw that ray towards the right. Okay, last one, opposite rays. These are 2 rays that share the same endpoint and they form a line. So they're rays that are going opposite directions. In this case, we have this point C, and we're going to look at that like that's an endpoint, and I'm going to have C going towards B. That's a ray right here. But I could also have C going towards A. So C going towards A. And again, that could be written the other way as long as you switch the arrow on it. Those are considered opposite rays. All right, let's look at a couple of these problems. This first one says, what are the names of the segments in the figure at the right? Well, when I first look at that, well, I think that's a line because the arrows at the end, this is actually a line. But within that line, you can see there are chunks that would be the segments caught up in it, and that's what they're asking about. What would those segments be called? So there's a lot of different ones that I could write. I could write DE, that would be a segment within there. Now remember that you just put a segment over the top, not a line. I could also call that ED. All right, we're going to just assume that you can write those either way. I'm not going to write it both ways every time. All right, EF would be another little segment that's inside there. And then I put a little segment over the top of that. But I could also like ignore the E and I could write segment DF. That would be another. Those are the 3 segments that you could write from this picture. All Right? What are the names of the rays in the figure? A ray, remember, has an endpoint and then goes forever in the opposite direction. And there's several that we could do here. I'm going to try to do this in a sort of organized way. I'm going to start right here at D, and I'm going to say it goes forever this way. So I could write that as a D going towards E. So I could write ray DE. I could also write ray DF. That would really kind of be the same ray, but it would just be different ways to write that. So I'm going to write DE. Could also write DF if we wanted to. All right. Now, instead of starting at D, I might instead start at E. So if I start at E and go that direction, I would have ray EF. All right. Now, that's if I'm always going kind of towards the upper right. What if I was coming the other direction? I could write the rays going the other direction. I could start at F here, and I could go this way. Or I could start at E and go this way. Those would be other rays to write, and they would be considered different because they're going different directions. So I could say F is going towards E, or F is going towards D. That's really the same ray, but written different ways, because it has the same end point. All right, I could say it starts at E and heads towards D. That would be another. That's pretty much all the different rays that I could write on that problem. Now, which of the rays in part B are opposite rays? Okay, well, opposite rays, remember, have the same end point and go in opposite directions. And the only one, I mean, like when I wrote D here, I never said I start at D and then go towards, I got nothing to go towards. I don't have another point. Just like I didn't say F going this way. The opposite rays are going to have to be centered around this point E, because E could go towards F or E could go towards D. So the two, when they ask me which two are opposite rays, the E going towards F and the E going towards D, those are the opposite rays. All right. All right, the next new thing we're going to talk about are postulates. Postulates are kind of like rules that we have. In this case, they're statements. But postulates are special because we accept them without proof. And there isn't much in math that we accept without being able to prove it. And we'll do proving in geometry. But there's some basic things that we have, building blocks, or what they call them, building blocks, that you have to start with in order to build this subject of geometry. So there's a handful of postulates, and we'll throw them in every once in a while as we need them. There's several here that talk about lines. So through any 2 points, there's exactly one line. It's kind of like your classic postulate that you hear from geometry. Through any 2 points, there's exactly one line. Okay, got it. If two distinct lines intersect, they intersect in 1 point. So you can see my two lines intersect at this 1 point C. Here's another one. If you have two distinct planes intersecting, and this is a nice picture. I'm not very good at drawing this three-dimensional looking picture here, but these are your two planes that are intersecting. Wherever they touch is their intersection, and they are going to touch along this line here. And remember that we draw these planes like a parallelogram, but we assume that they would continue on forever, and so we show this with a line to show that that intersection would continue forever. So their intersection is line ST. All right, let's do some problems like what you're going to see on your homework. It says each surface of the box at the right represents part of a plane. What is the intersection of plane ADC and plane BFG? All right, so let's look at this little cube we've got. Now, we have plane ADC. So you have to find where A, D, and C are. Here's your A, D, C. Okay, I picked 3 points, or they picked 3 points off of this plane. So you can see ADC is really the top of the box here. So we're talking about this plane up here, the top of the box. And BFG, let's see where that's at. BFG, that's the right side of this box. So the question they're asking is, what is the intersection of the top and the right side of the box? Well, hopefully you can see that it would be this line right here. Now it looks in the picture like it's just a segment, but remember that this is representing part of a plane. So since it's assumed to be a plane that would extend forever, the intersection is actually the line BC, not the segment. So the BC and put a line over the top. That's the intersection. All right, let's see if we can do this next question. It says, what are the names of two planes that intersect in BF? So I've got to find my line BF here. It's right here. Okay, it's this front edge. And on this edge, the two planes that create that edge are the front of the box and the right side of the box. So on the front of the box, I'm going to pick three letters. A, B, F, and E are my four options. I just have to pick three of them. So the name of the two planes, I'd call it plane ABF and plane, now I have to pick 3 points on the right side. I'm going to go BCG. Now we can name this differently. You might have picked a different three letters, and that's okay. Let's look at a fourth postulate. It says, through any three non-collinear points, there's exactly one plane. Now this is the first time that this has actually come up. I've just kind of breezed over it. But it is important to recognize when I'm talking about creating a plane that this word non-collinear, that's important. When I pick my 3 points off of that plane, they can't all lie up on the same line, because instead of having, like for instance, I don't know if this is going to make sense, but I stick another point right here. See if I can make that line up so that it lines up with Q and S. These 3 points could actually have like a vertical plane slicing through right there. So that would not necessarily designate just one plane. I could come vertically down through that too. So your points have to always be non-collinear to designate that specific plane. All right, so let's look at our questions. What plane contains point N, P, and Q? Shade the plane. Now, your homework is going to say that same thing. It's going to shade the plane, but the only way to shade it is to redraw the whole picture. We're not going to mess with that. So let's ignore the shade the plane part, and you can do that on your homework too. Not going to do it. Not going to shade it. Let's just name the plane that contains N, P, and Q, or what plane it says. So find N, P, and Q. Okay, that appears to be the bottom of the box here. So that's what I want you to write. It's the bottom. Now, it can get trickier than that. It says, what plane contains J, M, and Q? What plane contains J, M, and Q? Shade the plane. Okay, well, I'm not going to mess with shading it, but it's tricky because you got J, M, and Q. That is not one of the 6 faces of my box. But if you could imagine, if you sliced through this box, I'm not going to be able to draw it neatly, but you could slice through this box with a plane, and it's going to come from this top edge up here and slice through at a diagonal down through here. And it would be like in a diagonal in the middle of your box coming through here. So that would be the plane right there that we're talking about. So what plane contains that? I'm going to say, all right, it's not a side, so I can't say the bottom or the top or the right. I'm going to say it comes from the top left to the bottom right. That's where the plane goes. All right, this is the last one here. It says, what is the name of a line that is coplanar with JK and KL? The name of a line that's coplanar with JK, all right, JK is this edge right here. Here we are, JK. KL is this one right here. So these are both on the top of the box. So I have to find another line that's on the top of the box that will be coplanar. So you pick, you have options. What's another line you think that would fall on the top of the box? Hopefully you can see that ML would be, or you might have chosen JM. Either one of those would be a line that would end up being coplanar. All right, that's a lot of information, a lot of terminology, a lot of notation. Sorry, I know it's long. Your homework is 1.2 on page 16 of your textbook. These are the problems that you're going to be doing. All right, if you were in class, we would have started it together, but I'm not going to mess with that on the video. You can go ahead and jump in and work through those problems. Good luck.